Hello everybody. This is a demonstration video of our real-time hazard monitoring and notification system made for our Idea Lab SEE. Let's start with going over the components used for our project.
Let's begin by taking a look at the Arduino code that powers our sensor readings. We are using an Arduino Nano board for our project. Each mentioned sensor here is connected to either a digital pin or an analog pin on the Arduino board. The Arduino Nano board receives raw values from each of these sensors. The sensors we have used are soil moisture sensor, smoke sensor, LDR sensor, and flame sensor. The first three sensors are connected to analog pins, while the last flame sensor is connected to a digital pin. Now, let me show you the hardware setup. This is the box inside which we have housed all the sensors, one in each corner. First, this is the Arduino Nano, the microcontroller that reads all the sensor values and communicates with the laptop using this cable. Next, we have the soil moisture sensor. It checks for flood or water accumulation in our project. Next, we have the LDR sensor, which senses brightness of the surroundings, and it is useful to detect power outages or sudden bright lights. Next up, we have the flame sensor. It gives digital output, either high or low, depending whether there is a flame or not. And finally, this is the MQ2 smoke sensor, which detects gas or smoke in the environment, depending on the concentration of the gas. The right port, COM5 in my case, and the right board, Arduino Nano in our case. After clicking upload, what Arduino Nano does is it reads raw values from the sensors and then combines them into a single line separated by commas, which is later fed to the Python backend and can be used either for sending notifications or updating the dashboard. The output is in the following format: 4 values separated by commas. The app.py script, it receives serial data from the Arduino. It parses these values into a dictionary. Now, the most crucial part of this script is the /data endpoint. What this does is, it returns sensor values and a timestamp in JSON format so that it can be updated in the front-end dashboard. Also, we have a separate function for the notification logic itself. What happens here is, based on predefined thresholds, notifications are sent to the users using a service called Pushbullet. Flame and smoke sensor notifications are sent almost immediately without much delay, as fire is very hazardous, whereas the other notifications are sent after a fixed amount of time to avoid spamming. Also, if the values exceed the threshold for a very long time, like 30 seconds, a unique critical notification is sent for necessary action to be taken. This is what our backend does. Let me show you the front end. We've used an HTML file for basic layout and Bootstrap for responsiveness. We have one CSS file for basic themes and dark mode, which I'll be showing you later, and even the blinking effects in case of alerts. Also, we have a JavaScript file here. It's a very important piece of code here because what it does is it fetches the latest data from the Flash server, and then this data is used to update everything in the dashboard, basically everything. Let me now demonstrate the working of our project by starting a local Flask server. We go to the terminal and then type python app.py. We get a link which redirects us to our dashboard. So our dashboard contains sensor values of each sensor, and then we have real-time line graphs. We also have a Pushbullet alert log here. All the notifications sent get recorded here. We also have a scrollable log of recent readings. In addition to that, we also have a dark mode. Now let's go ahead and test each sensor. This is one of the devices connected with Pushbullet that will be receiving notifications. First, I'll dip the soil moisture sensor partially in water. A warning is triggered and a notification appears on the other phone. This alert indicates either water leakage or precipitation. Now When I immerse the soil moisture sensor completely, the alert is different. This indicates a flood. After around 15 seconds of abnormal readings, a critical notification is issued. Critical. Next, for the LDR, I'll turn off the room light. The system will detect darkness and then send a notification, possible power cut. Power anomaly. Now, when I turn on my flashlight and point it at the LDR, it detects sudden brightness. And then a possible fire alert is sent. Now for the smoke sensor, I'll place an incense stick near the MQ2 sensor. I'll let the gas collect around the sensor so that its concentration increases, and thus it triggers a notification. And here we have the notification. Cabin air contaminated. Finally, for the flame sensor, I'll point a flashlight directly at the sensor to simulate flame. Since flame sensor works on the principle of infrared radiation, a phone flashlight can be used to simulate a flame. To conclude, this is our complete hazard monitoring system. It can be deployed in homes, server rooms, warehouses, or even agricultural fields. It offers real-time monitoring of multiple hazards, instant alerts using Pushbullet, and an interactive and customizable dashboard to analyze the values. Thank you for watching the demonstration.